do not avoid stress. This does not mean, of course, invite problems into your life, but stress is a normal part of life and it's there for a good reason. And stress also can be very positive. Stress can motivate you, can help you reach your goals, can help you set aims. Stress can be extremely a positive power in your life, so do not avoid it. But you need to learn how to deal with it.
Ask Different, the podcast by the Einstein Foundation.
My name is Anton Stanislavski. Welcome to the podcast. Life is full of stress. I think lots of us can agree on that. Modern life can be overwhelming at times, yet some people seem to handle stress much better than others. For some, stress can become harmful and even lead to chronic illness, while others appear to be relatively unaffected, even under the exact same circumstances. What makes certain people more resilient to stress than others? And what are the biological foundations of this resilience? These questions take us from humans to mice and to our guest today, to Dr. Sarah Ayash, a neuroscientist at Charité Berlin, as well as an Einstein Independent Researcher. Hi, Sarah. It's so nice to have you here on the studio and on the podcast.
Thank you for having me, Anton. I'm happy to be here.
So most people, at least the ones that I know, are trying to avoid stress whenever possible. But you, on the other hand, you've chosen to dedicate a lot of time of your work to studying stress. Why? What's so appealing to you about this topic?
So for decades, we have been conducting research on stress, and specifically on stress-related mental disorders, so what we call stress susceptibility or stress vulnerability. And there is no doubt that this research allows us to understand a lot about stress and also to develop therapies and treatments. But it's also clear, especially after the corona pandemic, that the frequency of stress-related mental disorders around the world remains very high. So we, as resilience researchers, we are trying to address the problem by approaching it, if you so will, from the opposite direction. Instead of asking why some people become ill after stress exposure, we are asking why the majority of people remain healthy. Because research tells us that 2/3 of us are resilient in the face of a major life adversity. So resilience is the norm, it is not the exception. Now, in the past, the thinking was the mechanisms in the brain or the activity in the brain happens only when we develop illness. So resilience was thought to be a passive process. It's insensitivity to stressors. But today we know that this is completely wrong, that actually resilience involves a lot of mechanisms in the brain and uses a lot of resources from the brain to generate this outcome, this stress-resilient outcome. So we are now saying perhaps if we understand those mechanisms, we can then promote resilience and also treat individuals who suffer from stress-related mental disorders. So we are, researchers investigating stress resilience are more interested, or if you so will, fascinated by health rather than by illness.
You have your own lab at the Charité for your research, and you're working mostly with mice for conclusions about human stress. Why mice? How are they suitable for this?
Yeah, so mice are extremely social species, and this is what makes them very suitable for our stress research, especially because you want a stress that is what we say in science translational. So what we mean by that, you want a stress that humans are familiar with or are exposed to. And most of our stress nowadays in the 21st century is social stress, and mice can be socially stressed. Also, mice are very individualistic. So what do I mean by that? I work with genetically identical mice that also have a very similar background and a very similar environment, if not even identical. And yet, when I stress them, I observe completely different outcomes. Some mice are resilient, and we can talk about this in a little. What does that mean in mice? Some mice are susceptible. Some mice do not even learn to avoid threat. This is quite remarkable because if you think about it in humans, we can always say, yeah, of course, people respond differently because people have a different genetic background. They also have a different cultural background, environmental background. Even siblings from one household grew up differently. They went to different schools. They had different friends. But what is really remarkable is that in mice with that identical background, you still observe these differences. So clearly, there is an evolutionary advantage to not all of us responding in the same way to stress.
So there are different stress types in humans and in mice.
Yes.
And you're trying to find out what are the mechanisms behind it.
Exactly. But we are not interested in attempting different types of stress. Instead, we're saying if I use the same stressor, which in my lab is social stress, if I stress all mice with a social stressor, why am I observing that some of them are susceptible to that stress and will develop anxiety, and why others are resilient and will not develop anxiety? So we are more interested in the different outcomes following the same stressor rather than investigating how different types of stressor could produce a different outcome.
So let's talk about the experiments you're doing with the mice. Can you explain the broad approach?
Sure. So let me start by explaining male mice. So male mice in nature, they are territorial. So what does this mean? That each male defends his territory. Each male has multiple females. He can also tolerate, let's say, younger males, but after a certain age, these males need to be out of his territory. And so we took advantage of this situation that happens in nature and tried to model it in the lab. We call this model the chronic social defeat model. So in this context, we introduce a younger male who is also smaller in size into the cage of an older and larger male.
Sounds stressful.
Yes, already, before anything else, absolutely. And the older and larger male is also sexually experienced, while the younger one is not. And we know that sexual experience renders mice particularly aggressive, male mice at least. So what will happen is that the owner of the cage will attack because he wants to evict this guy from his territory. And if he cannot evict him, at least to make it clear who's the boss here, to establish hierarchy. So we use this situation. We stress the mice for 10 straight days. We do 10 days because we want this stressor to be chronic. So we are trying to model as much as possible a situation that is happening to humans. And you can think of this situation as bullying. So this is really the most, I would say, similar situation for humans comparable to chronic social defeat. It's a bullying situation. For 10 days, he is entering the cages of different mice every day where he is being attacked, he is being defeated.
I feel a little sorry for the younger mice.
Yes, but we also have to say, this is a situation that is ecologically valid. Mice are equipped to deal with that stressor. And I actually want to comment because at the beginning you also mentioned how we are all avoiding stress. Do not avoid stress. This does not mean, of course, invite problems into your life. But stress is a normal part of life and it's there for a good reason. And stress also can be very positive. Stress can motivate you, can help you reach your goals, can help you set aims. Stress can be extremely a positive power in your life. So do not avoid it. But you need to learn how to deal with it. And even in that very stressful situation, we see that a good percent of these mice will be resilient after these 10 days of being attacked and being defeated. And of course, others will be susceptible.
Do you have numbers on that? How many mice are resilient?
Yes. So if I were to defeat 100 mice in an ideal group, actually, I will have 33% resilient, 33% susceptible, and I will have 33% of yet a third group that does not even learn to avoid threat. So it's a group that suffers from a phenotype of impaired learning. So maybe the best term to describe this group is resistant, not resilience. And here's why. It's not necessarily an advantage for you to approach threat. If you were attacked for 10 days by the same group of, let's say, people, why is it correct that on the 11th day when you see them, you go towards them like nothing has happened? So we have this group of mice that we call non-avoiders. They do not learn to avoid threat. And with other tests, we were able to show that these mice actually suffer from an impaired learning phenotype. They're unable to learn threat. And right now we are running investigations to understand what is happening in the brain that is resulting into this behavior. But what is really interesting is that they are equally represented in a group of mice as susceptible and resilient, so 33% per group, showing that there is an advantage to this particular behavior in specific contexts. In our context, it's not advantageous, but maybe in other contexts where you definitely cannot avoid stress, maybe it is advantageous that you are resistant rather than resilient or susceptible.
To be honest, the third group sounds brave to me or fearless. Even after 10 days, they will still go into the same situation again.
I understand where you're coming from, but I would not call them brave because, of course, in this social situation, there's a bigger room for interpretation. You can say they are brave. You can say they are, courageous or whatever. But we hypothesize that not only is it maladaptive to approach danger when you know it's danger or after an experience of danger, but it's also anti-survival. However, to put this to test, we needed a situation where there is absolutely no questioning what is the correct behavior here. And so for that situation, we train these animals that there's a certain tone, it's kind of a beep, that predicts that they will receive a very, very, very mild foot shock. So It's like an electrical shock on their foot. It's very mild, it causes no harm, but of course it's unpleasant for them. But we train them that you can actually avoid that foot shock if you walk to the other side of the chamber. So the chamber was divided into two parts. If you hear the tone and walk to the other side of the chamber, that's all that is requested from you. You will not get that foot shock.
And there's still a group of mice that don't do it.
We trained them for 7 straight days. And what we observed was the two groups that learned to avoid threat. So the susceptible and the resilient both learned to avoid threat. And we will talk in a second, then what is the difference between susceptible and resilient? But now, on the level of learning to avoid the threat, both susceptible and resilient, they learn to avoid threat. But this third group that does not learn to avoid threat, after 7 days of training them in this foot shock tone context, they still failed to learn. They did not get it, that I can avoid the foot shock if I walk to the other side of the chamber. And this allowed us to conclude that this is not being brave, which of course is also reasonable hypothesis, but it's actually an impaired ability to learn threats.
Okay, so we have that group. And then we have the resilient ones and the susceptible ones. What are the differences between these two groups? Can you talk us through?
Okay, so I'm glad you asked, because when we developed this model, we wanted a model that is as much as possible mirroring a situation in humans. This is why we do mouse research. We can observe a situation in humans. We can identify, let's say, correlations. But then to understand the underlying biology of these behaviors and of these, phenotypes in humans, we need an access to the brain. And this we can only have with mice. It's not only about the access per se, but it's also the ability to establish causality. Even if I can access the human brain, for example, to a certain extent we can with techniques like brain imaging, like magnetic resonance imaging, but still I cannot directly interfere. And in mice, I can directly interfere to know, yes, indeed, is this mechanism needed for resilience or it's not needed for resilience? It's just correlating. So, coming back to your question, we identified 2 characterizing features of resilience in humans. And hereby this was not my research, this was research done by other scientists working on humans. So what we see is that resilient humans are able to tell this situation is safe and this situation is not. And they are also able to relearn that the situation that was threatening is no longer threatening. So what does this mean? Resilient humans, they display something we call threat safety discrimination. They do not show fear generalization. They understand if I come to work and I have a problem with a colleague who is stressing me, then I do not need to hate every single colleague in my, company. I do not need to have now a problem with my company, with everything there. I recognize my problem is with this single individual. This is threat safety discrimination. Meanwhile, individuals who suffer from stress susceptibility, they display fear generalization. I have a problem with you in my work, I'm going to avoid everyone. I hate everyone. Everyone in the company is targeting me. Everyone is against me. That is fear generalization. The other ability to relearn, we call it extinction responsiveness. So what this means is the following. If we stay with our example, if this colleague changed his behavior, maybe, I don't know, he was going through a difficult time and acting particularly difficult because of that, and now he recognized this is inappropriate and he changed his behavior. A resilient individual would be able to relearn an association with this colleague. Sure, once upon a time things were not good, but now I understand that things are better and I no longer need to avoid him or, not interact with him. Meanwhile, a susceptible individual will always avoid this colleague or will always avoid the situation that was threatening, even if it actually no longer is, because sometimes things change in life. They always do, not sometimes. And so, again, back to your question, we identified a group of mice after this chronic social defeat. The resilient mice will only avoid individuals that come from the strain that attacked them. Because in mice, we have different strains. So we are attacking them for 10 days by different individuals, yes, but all of these individuals, if you saw well, like in human language, come from the same family. When we give them the opportunity to interact with individuals from another family, they interact perfectly well. They're social species. They're happy to interact with the other guys and to be around them. But they will be very clear they don't want to be near those other guys there. But the stress-susceptible mice will avoid everyone. So they start sitting alone, in the middle, avoiding interaction, even with mice from a completely different family that had nothing to do with their negative experience. And this is what we call fear generalization.
And it's roughly 1/3 of the mice that you were
Exactly.
observing.
1/3 are resilient, 1/3 are susceptible, and 1/3 are the group we talked about earlier that fails to learn.
What group you belong to or the mice belong to,
Yeah.
is that determined strictly biologically?
So that's a good question. This is now exactly the point of why are we using mouse models. So now we understood a situation in humans. We successfully modeled it in mice. We see these same behaviors in mice that we see in humans. Now comes the next step, which is the step why we are using mice in the first place. What is happening in the brain? And this is now the question. Are you born resilient or susceptible? Or is this a process? And our findings so far suggest this is indeed a process. You could have characteristics or let's say personality traits that make you more leaning to resilience or more leaning to susceptibility. But eventually, this does not mean you are somehow judged forever as resilient or susceptible or stamped forever. Resilience is a learning process. You can learn to be resilient. You can learn to have these mechanisms take over in a stressful situation rather than the mechanisms that make you ill.
That's very good news.
Yes, indeed. Yes, yes. It's not, as I said also, we should not avoid stress. And that's maybe a point we can comment on later. And how stress is actually very beneficial, by the way, for building resilience. One of the best ways to build resilience is by exposing yourself to stress. Now, this stress, of course, has to be mild. It should not cross your tolerance threshold, certainly. But it should not also be too mild where you do not feel threatened. It should be enough to do what we call to activate your stress response mechanisms in the brain, but to present more a challenge to your brain. So one of the things that seriously worry me personally from what I observe around me is how people are raising their children. They want, especially, let's say, in this part of the world, in economically advanced countries, it seems like there's this goal that my child should live a stress-free life. I would argue this causes more damage than training your child that he needs to interact with stress and he needs to learn how to manage it, because sooner or later he will need to interact with stress. So we see that, for example, in humans, adults who had negative working experience, or let's say stressors working when they were younger, when they were, teenagers, those adults manage stress very well in companies when they start working, compared to adults that started working for the first time later on, were not exposed to work stress when they were teenagers.
I will show my future children this interview if they complain that their life is too stressful.
Yes, absolutely, yes.
You told me before the interview that most research on mice was done on male mice, and now you're trying to add female mice into it. Why is that important? What are you observing?
Yeah, so for the past 40 years, if you search for words on stress resilience and on mice, you will quickly recognize that 95% of that research was done on male mice. And the reason for that is the same reason why the chronic social defeat model is amazing in the sense that you are actually modeling a situation that happens in nature. So you are not artificially stressing your mice, and you are able to generate a big number of mice that are resilient and susceptible, and to study them in response to the same experience. These are all incredible advantages to that model. But those same advantages were the reason why we skipped female mice, because female mice in nature do not attack another female mouse in her territory. They're not territorial. However, now we are learning that female mice do stress other female mice, but there are different contexts and situations where they feel threatened and where they do that. And here, I would like to mention my colleague, Emily Newman from Boston University. Emily was able to show that female mice will attack other female mice, but not for territory, but for her male. So if you house her with another male and they develop partnership, and then you take that male out of her cage and introduce another female, that female will attack the other female. So it's called rivalry aggression. It's not territorial, it's rivalry aggression. So now we are understanding what stresses female mice in nature. How can we model this in the lab to also start investigating resilience in females? And here I really want to stress, I'm not arguing we should study female mice for political reasons because we want equal representation of female and male. These arguments might be completely valid. But as a scientist, I would argue we cannot understand any mechanism in the body, including the brain, if we do not understand how it functions similarly and differently in both sexes. We do know that certain stress-related mental disorders are more likely in males, and others are more likely in females. So clearly, these brains are equipped, at least on some level, in a different way. And if we understand those mechanisms in both sexes, then we can also understand what is, if I may put it so simply, what is lacking in the male brain, that if we induce, we can also make males safe against that particular type of stressor. And of course, the opposite is true. What is missing or what is different in the female that we can maybe induce or build to also make females more resilient in that aspect. So purely from a scientific perspective, we cannot claim that we have a full understanding or a complete one of resilience mechanisms if we do not investigate it in both sexes.
I've learned a lot. I've learned that avoiding stress is not a good idea.
No.
Certain amounts of stress are actually healthy. Are there other insights that are translating into human stress behavior that you want to share?
Yes. So maybe, for example, we can think of strategies that people can induce more stress in their life, but in milder forms, right? So first thing, like what I noticed now after Corona, many people, because, a home office or doing things virtually became much more possible, obviously, after Corona. And on the one hand, this has a lot of advantages, no question, yeah? And it helped solve a lot of problems. That being said, try to reduce the tasks you do virtually as much as possible. I mean, let's take the interview today. You offered me to do this online. I live 1 hour away from where the studio is. And of course, we know, public transportation is not exactly punctual these days.
It can be stressful.
Can be very stressful, absolutely. So I could just simply say, sure, let's do it virtually. I'm in my home, I'm relaxed, I have my cup of coffee. This is perfect, why not? But I consciously said, no, I will wake up early, get ready, take a train for 1 hour, risk getting lost, risk missing the train or the train coming late, to put myself in this situation, to expose myself to this stress in order not to have my brain live in this safe space all the time, but for it to be challenged and to be also stressed in a digestible, let's say, amounts. So this is one thing you can do. Think of the things in your life, the decisions you take, even small decisions, appointments you show up to, how you do your work, socializing, these things that maybe you are starting to choose always the easiest way. But this easiest way could be harmful for you on the long run or in the future. Think of your psychology as if you have a psychological immune system. So how do you immunize the body from illnesses? You inject the virus into the body, right? And you inject that virus in a mild, weaker form, but it's enough to wake your immune system and for your immune system to register there is a threat. But it does not overwhelm it to the extent where you are, dead because of the virus. And that is enough for your body to be immune against that virus when it encounters the real one in the future or the stronger one in the future. It's exactly the same for your psychology. There's an immune system here that needs to be challenged, to be trained so that it's stronger against future stressors. So this would be my take-home message to the listeners.
Certain amounts of stress are actually healthy for you.
Yes.
That's at least my main takeaway of our interview with Dr. Sarah Ayash today. Thank you so much for being here.
Thank you, Anton, for having me.
And as always, thank you so much for listening. That's it for today's episode, but we have plenty more episodes to listen to. You can also follow the podcast to not miss any future episodes. And of course, if you give us a rating, if you leave a comment, if you tell your friends and family about us, that helps a lot. My name is Anton Stanislavski. Goodbye.
Ask Different, the podcast by the Einstein Foundation.